we're going to just use two trig identities with this. Remember, sin theta over cos theta is identical to tan theta, and also sin squared theta plus cos squared theta is identical to 1. So I don't want to touch the cos theta here. I want to try to rearrange the sin theta and the tan theta in terms of cos. So the first thing I'm going to do is, I know that if sin theta over cos theta is tan theta, then I know that sin theta is tan theta times cos theta. So I can write this straight away as 4 cos theta minus 1 is 2. And I said sin theta, remember, is tan theta multiplied by cos theta. That's from this identity here. I can multiply that out, so I end up with 4 cos theta minus 1 on the left hand side, and I get 2 tan squared theta now cos theta. So here I've got a cos theta, but I've also got a tan squared theta. So how am I going to deal with that? Well, I'm going to use this identity here, and I can say that if sin squared theta, or I'm going to use a combination, I should say, of this identity here and this identity here. First, I'm going to say if sin theta over cos theta is the same as tan theta, then sin squared theta over cos squared theta is the same as tan squared theta. So I can replace that here. I will end up with sin squared theta over cos squared theta multiplied by cos theta, and on the left hand side I still have this. Now I can cancel this out here, so I end up with, we can write this out again, 2 sin squared theta over cos theta, and on this left hand side I've got 4 cos theta minus 1. This is where I use this identity here. Sin squared theta I have over here, so this identity. So I end up with sin squared theta, remember, is the same as 1 minus cos squared theta from this one here. So I'll get left hand side 4 cos theta minus 1 equals 2. And I can replace sin squared theta here with 1 minus cos squared theta. So I have 1 minus cos squared theta over cos theta. I'm going to multiply both sides by cos theta, and I get 4 cos squared theta minus cos theta. I need to multiply both these terms by cos theta, and that removes it from this side. I end up with 2 into 1 minus cos squared theta. That then, if I multiply that out, I end up with 4 cos squared theta minus cos theta equals 2. So multiplying out this bracket, minus 2 cos squared theta. If I add this to this side and I take away 2 here, I get 6 cos squared theta. So I've added that 2 cos squared theta that side, minus cos theta minus 2 equals 0. And that's what this is here. So I have done part A. Okay, part B builds on part A. So let's take this away. Okay, well, actually we don't need these either. So let's have a look here at this. We've got 4 cos 3x minus 1 equals 2 sin 3x tan 3x. Well, look, this is like this, but theta equals 3x. So I could rewrite this as 6 cos squared 3x minus 1 equals 2. Getting confused with these two here. I could rewrite it as this. So it would be 6 cos squared 3x, because theta is 3x, minus cos 3x minus 2 equals 0. Okay, if I say cos 3x is, say, another variable. Let's call it p. I could rewrite this, so I'm saying cos 3x equals p. I could rewrite this as 6p squared, yeah, minus p minus 2 equals 0. And this is a quadratic, so I can factorize that. I'm going to do this by inspection. So I know that this times this term, whatever this is, there's going to be a p here and a p here. The coefficient of this will equal to this. Let's try 3 and 2. I know that this term here, whatever this constant here and here multiplied together must make 2. So 1 will be 2 and 1 will be 1. I'm going to try it this way round, but I could have tried it the other way round. I just need to check and see my middle term has to equal minus 1. Well, I know these signs are going to be opposite because I've got a negative here. So let's see if I've got, so far we've got 6p squared, so this multiplied by this. Then I might have 4p, so that's got to be negative. Yeah, because if I've got 4p, take away 3p, I end up with a positive p. So I need to have minus 4p plus 3p, and that will equal negative p. And then I've still got here minus 2 times 1, which equals minus 2. So I've solved this, or I've factorized this just by inspection, just by trying out some numbers, but an educated guess of some numbers here. Okay, so if I know that this multiplied by this makes 0, I know that 3p minus 2 will equal 0, which would imply that p equals, let's take the 2 onto that side and divide by 3, so p equals 3. And remember, p is cos 3x, so here cos 3x equals 2 over 3. And likewise, I can do the same with this. 2p plus 1 will equal 0. So it's one of these two solutions here, one of them 0. So I would end up with p equals minus 1 over 2, minus a half. And remember, p is cos 3x, so I'm going to substitute it back in. So I get cos 3x equals minus a half. I need to solve this for 0 between x is greater than or equal to 0 or less than 90. I know that it's 3x here, so my solution is going to be 3 times, it's going to be within 3 times of this range here. So 3 times 0 obviously is 0, 3 times 90 is 270. So my cos graph, so let's just draw a sketch of a cos graph here. My cos graph will have 90 here, it will have 180 here, and it'll have 270 here. And that's where it's going to go up to, because 3 times 90 is 270. So if I take one solution here of 2/3, if I do that on my calculator, I would do cos to the minus 1 of 2/3, and I get 48.2 degrees. So 3x could be 48.2 degrees, which would make sense on here. 2/3 is up here, and my 48 will be down here. I'm not going to have another solution because that's past the 270, if you see. Yeah? So only one solution for this. And if 3x is 48.2, then x would be approximately 16.1 degrees. I didn't round this in the calculator, which is why this is 0.1 here. Okay, let's take the other one. If cos 3x is minus a half, then 3x will equal to cos to the minus 1 of minus 0.5, yeah, minus a half, which equals 120 degrees. Now 120 degrees, that would also make sense, that's here, but there's another solution within my range here, which we can see from this, from our symmetry, is 240 degrees. So if 3x equals 120 and 240, then x will equal 40 degrees. So divide 120 by 3, and it can also equal 80 degrees. So we've got three solutions there, 16.1, just write it out here, 40 and 80 degrees. Let's tidy that up, and that's my solution here.